Hello, my dear future engineers. How are you all doing? I hope you all are doing well. So in previous lecture, we saw interference and I said interference is one of the most important topic because this interference is very much important for wave optics also. Okay. So as we have finished that, okay, principle of superposition, in that we saw interference, and in interference I said, so what is superposition? Superposition means two waves are going and combine with each other. So I said that there are three ways of superposition, out of which one was interference. Another one is what? I gave you three examples. Another one is beat. In beat, there are two waves which are having frequency almost similar to each other. And the third category is today's topic. What is that, sir? Standing wave. So reflection of wave. Okay. So basically in all three cases, there are two waves, two or more waves. They are going to come and meet at the same place. This is what is called superposition. Okay. So before going into today's lecture, let me give you some demonstration videos. Okay, for your better understanding. So see, what is this? This is a simple harmonic motion. Why, sir? Because this particle is oscillating to and fro about its mean position. Let me say this is its mean position. It is going what? Up, down, right? So it is going up and down about its mean position. Therefore, what do we call it as? We call this as simple harmonic motion. Here, if you see each wave individually, these things I have already demonstrated you. Okay, I don't know why I am blabbering. So this thing I have demonstrated you like this, right? So this is a simple harmonic motion. This is simple. This is simple. But if you see everything combined, okay. So each spring is undergoing simple harmonic motion. But if we see everything combined, what can we see? We can see a beautiful wave pattern in it. Any difficulty? We can see a beautiful wave pattern in it. Okay. Now, as we have discussed in the previous lecture about interference, so let me demonstrate you. I have taken two waves of equal wavelength. Sir, red and blue don't have equal wavelength. So light, okay, if I am talking about light, then red color light and blue color light doesn't have same wavelength. In this, to differentiate these two waves, we are using just colors. Okay, we are not talking about the wavelength of light. We are talking about just wavelength of this wave. Okay, so don't get confused. Both the wavelengths are equal. If both the wavelengths are equal, and deliberately I have taken same amplitude, if both of them are equal, then what will happen, sir? As they both are in phase, you can see both of them have their maxima at the same point, minima at the same point, right? Maxima at the same point, minima at the same point. So what will happen, sir? If I have two waves which are moving with the same speed, frequency is same, deliberately I have taken the same amplitude. So if you see, when both of their maxima are at the same point, they are in phase, right? Maxima same, they are in the same direction, right? So the output, see, this is 1 meter, this is 1 meter. So my output is 2 meter, A1 plus A2. Now after some time, let me just take this slow. Okay. Okay, let me reduce this velocity of the wave. If you see, when one wave is having minimum value, another wave is having maximum, it means what? One wave is in this direction, another wave is in this direction, right? So they are opposite. They are opposite in nature. What is amplitude, sir? I am getting minima. Okay. When they are in same phase, see, maximum is in the same place. What do we get? Maxima, constructive interference. Sir, what will happen if the amplitudes are not same? Is interference still possible? Yes. I have deliberately taken one value to be 1 meter, another to be 0.5. Now see, the maxima and maxima are in the same plane. So they are in phase to each other. What is happening when they are in phase? When they are in phase, this is 1, this is 0.5. So my output, this is 1, this is 0.5. So output is 1.5, right? See here, My output amplitude is 1.5. A maxima is equal to A1 plus A2. We are still getting the maxima, but it is not constructive interference. Constructive interference means both should be having a value. If their amplitude is same, then we will be having constructive interference and destructive interference. Okay. Now see, one is having maxima, another is minima. So last time when we saw one is having maxima, another is minima, we got 0. It was completely dark, right? But here we are getting some amplitude. What does it mean? One is having amplitude of 1 meter in this direction. Another one is having amplitude of 0.5 in opposite direction. So 1, 0.5. What will be the resultant? 0.5 in this direction. So therefore we are getting 0.5. If I talk about this wave, one is one in backward direction, 0.5 in forward direction. What will be the resultant? A1 minus A2, right? So we are going to get 0.5 in this direction. Are you able to understand? So interference is still possible even if the amplitudes are not same, but we won't be getting complete brightness and complete darkness. Here we are not getting 0 amplitude, right? We are going to have some result. Okay. So next let us discuss about reflection of wave. So if one wave is going in forward direction and another wave, okay, another wave is coming in opposite direction. Another wave is coming in opposite direction. So one is going in this direction, another is coming in this direction. How can I write the equation? So this one, sir, y1 is equal to a sine of kx minus omega t. Why are you using minus, sir? Because we are going in forward direction, therefore negative. This wave can be written as a sine of kx plus omega t. Why omega, sir? Because this wave is going in backward direction, plus pi. Why do you use pi? Because they are in opposite phase, right? So when I have two waves which are exactly same but they are moving in opposite direction, when two waves are exactly same but moving in opposite direction, this will give me standing wave. Okay, so before going to that, let us see bounded medium. Okay, so have you ever seen this type of thing? If I am blowing a flute, it is an example of open column because the end are opened. Okay, so based on that, okay, have you ever seen people playing flute? So they will be closing one end, they will close a certain point with their finger. Okay, so they are trying to get the sound which they want. So in order, if I press this, the air will not come away from that place. If there are 7 holes and I am holding 3 holes, then air will not come out from that place, right? Are you able to follow? So if air is not coming out from that hole, it is going to come out from another hole. Based on that hole, okay, sound will vary. Have you seen something sitar, some guitar, something like that? If I am holding a guitar and if based on the place where I am holding my strings, okay, and I am vibrating the guitar. So based on the place where I am holding the string, my frequency will vary. Okay, so string of the sitar or guitar, air column of the flute, membrane of tabla, everything is considered to be a bounded medium. Okay, so there are two types of things. Okay, if there is a wave, there are two types of wave possible. One is, see, I am going to oscillate from my right hand side, it is going to go to left hand side. Okay, I am not going to move my left hand at all. So this is what we call it as rigid or closed. So just think, just don't think, just see, observe it, what is going to happen. If I am going to create a disturbance, I am going to create an upward disturbance. After reflection, what is going to happen? See, I am creating an upward disturbance, but after reflection, it is coming downward. Can you see that? I am creating upward disturbance, but after reflection, it is coming down. So remember, whenever there is a rigid or closed ball, what do you mean by rigid? Both the ends are closed. So best example is sitar. In sitar, okay, one end of the sitar is fixed here, another end is fixed there. So both the ends are fixed together. So it cannot move, end cannot move. We can just vibrate in between. So it is like this. Okay, the end cannot move. I can just go and vibrate it like this, right? I am trying to create some disturbance. Are you able to follow? I am creating some disturbance using my mouth. In that they are going to use fingers or thumb. So if both the ends are fixed, okay, if I create a disturbance, can you see it is going in upward direction, but while returning, while reflecting, it is coming in downward direction. So this is the thing that you should remember. Okay. So if both ends are closed, we call, if both ends are closed or both ends are fixed, we call it as rigid. What do I mean by open end? If one end is closed while another end is open. So if I am going to move this hand, okay, and when the wave come here, this hand is also going to move. Now observe what is going to happen. So last time when I didn't move my hand, the upward wave after getting reflected, it comes as downward wave. Can you see this? But when I move my hand along with wave, the upward wave will return back as upward wave itself. Can you see? Okay. Sir, unable to completely see that. Okay, so we have some demonstration for that as well. So this is over. Now let me see, let me have a fixed end. So both my ends are fixed, both my ends are fixed. I am going to run this pulse. What is going to happen? See, after reflection, it comes downward. Can you see this? After reflection goes upward, reflection downward, reflection upward. Can you see this? Now what will happen if I have a free end? After reflection, the end is free to move, right? So end is movable. What will happen? Upward wave will return as upward wave itself. See this. Can you see? As the end was, last time this end was fixed, it cannot move. But now this end can move, therefore. Okay. For better understanding, I will show you in another thing. So this one. If I have no damping at all, and the end is fixed, the end is fixed, it cannot move. Now if I run this pulse, I am going to send a pulse, okay, with a good amplitude. Let me start. Can you see this? It is going upward, after reflection it is coming downward. Upward because the surface is what? Rigid. So whenever we have rigid surface, upward wave will be reflected as downward wave. What will happen if I have loose end? See, going upward, okay, going upward, reflected, coming upward. Sir, why here it is changing the direction? Because this end is fixed, okay. So see, upward wave, downward wave, upward wave. So when the end are loose, upward wave will be reflected as upward wave itself. So these are the point you should remember. Okay. So I have taught you what is rigid and open. Open or free surface. Okay. When one end is fixed, another is open. That is what open surface means. So reflection of progressive wave in open surface. So don't worry about anything. Okay. Just a minute. So if it is open surface, there will be no phase change, right? So when the wave is going like this, okay. When the wave is going like this, after reflection, what will happen? Let me have this one, okay. So if my wave is going like this, okay, I am just going to give a pulse. It is going in this direction. If the end are open or free to, after reflection, it will come back in same thing. So if the equation is equal to y is equal to a sine of kx minus omega t, what will be the equation of reflected wave? Y is equal to a sine of kx plus omega t. Sir, why sir instead of minus you are putting plus? Because for forward direction minus, for backward direction plus. Any difficulty? So you need not remember anything. It is just simple based concept. I have even showed you how it works. And what will happen if I talk about rigid surface or closed surface? It means both the end are closed. What will happen, sir? If this is my wave, it is going like this. But after reflection, it will be a downward wave. Any difficulty? So if the equation of this wave is equal to y is equal to a sine of kx minus omega t. Why sir minus? Because it is going in forward direction. What will the equation of this wave? Y is equal to a sine of kx plus omega t. Y plus backward direction plus pi. Why sir pi? Because it was upward wave and this is downward wave. So in closed or rigid surface, there will be a change in phase. Okay. the phase change is going to be 180 degree. Okay, phase change is equal to how much? 180 degree. Remember this. Any difficulty? So I am going to teach you about standing wave. What is standing wave? When two identical wave, either it can be transverse wave or longitudinal wave, they are identical. What do I mean by identical? Amplitude is same, frequency is same. Okay, wave travel in a bound medium. So progressive wave, generally how can I write? Progressive is equal to a sine of ax minus omega t. This is my equation of progressive wave. This wave is progressing in x axis, displacement is in y axis. Okay, so this is equation of transverse. Bound medium with the same speed, the speed is same, but they are moving in opposite direction. Then by superposition, if they both are meeting, two same wave, but they are in opposite direction, one is going forward, another one is coming backward. When these two waves superimpose, they meet, okay, then what we get? The superposition, a new type of wave is produced which appears stationary. So when these two waves are meeting, we get something called stationary wave. Okay, we get what? Stationary wave or standing wave. When a wave is sent along a string, if I have a string, sir, if I have string, I am striking the string, okay. So a wave is going to go in this direction. As both the end are fixed, it is going to come back, right? So this wave and that wave are going to superimpose. Any difficulty? Let me try to show you that. So one wave is going so let me try to have both end as fixed one, and let me reset this. Okay, reset. See, without my knowledge, I have created. I have done, man. If you see this particular wave, okay, this is going reflecting back. But when you see, are you able to witness something like this? What I am trying to say. Are you able to witness something like this? Just see this particular part. Are you able to see something like this? Are you able to see? Let me stop damping. Let me slow motion. So what is actually happening? I am sending a wave. This wave, after reflection, I am sending one particular wave. After reflection, okay, both wave, one was the wave which I sent, another one was the wave which got reflected back. These two waves are superimposing. So if you see this particular point is not going to move. This particular point is not going to move. This. Just follow this point. So almost zero displacement. Okay, so here it is showing little bit displacement, but actually there is a point which is going to show zero displacement. So can you see how I made a standing wave? If you see, it looks like these points are at rest and the point in between are only moving. If you see this particular part, you will see upward, downward. No. Why? Now it is okay. Initially it was little bit less, right? Now it is okay. I can even increase the amplitude. Let it be 1 centimeter. So if you see, you will be able to witness upward, downward, upward, downward, upward, downward. So can you see that? It doesn't look like wave is going forward. It is just looking like up, down, up, down, up, down. It doesn't look like wave is going in forward direction. So how does it happen, sir? It all happened because, let me show you second harmonics. I will teach you what second harmonics is, but I am going to send a wave, okay, and that wave is going to get reflected because I am going to hold this steadily. So if you are able to see something like that, you will be able to see one wave is going like this, one wave is going like this, and the reflected wave will be coming like this. So what you will be able to see, after certain time this wave will come downward and this wave will go upward. So that is what you are going to witness. Try to see. Okay, I will try to make it. I am not doing any magic. I am going to create some wave. I am going to move this hand like this. Are you able to see that? It looks as if this particular half was going up and down and this particular half was going up and down. So when we are seeing, it looks as if it is just standing. Okay, it is not going. So generally if I send a wave, see, this wave is moving in this direction. See, this wave is going front and back, front and back. But just a minute. So creating it is a little bit difficult. If you see now, can you see some standing wave stuff? My hands are paining. Can you see this? Upward, downward, upward, downward, upward, downward alone. So this is how a standing wave is produced. So nothing but one wave is going in forward direction, another wave is coming in backward, and they get reflected and superimposed. So transverse standing wave are formed in the string in sitar. So either it can be string or it can be in air column. Okay, open air column and closed air column, both we are going to discuss. So example of open air column, okay, are like flute, okay, veena, whistles, everything are example of air column. So before coming to this part, okay, let me have a wave. Let me have a wave. Y1 is equal to a sine of kx minus omega t. Okay, and if I have another wave, plus omega t, why plus? Because it should come in opposite direction. Okay, if the end are closed, we are going to have plus pi. If the end are not closed, if the end is open, sir, is it possible to have open end? Yes, even with open end it is possible. Let me try to show you that also. So if I have loose end, can you see the standing wave? Can you see the standing wave? The wave, even see the last end is what? Open end. But if you see this particular part, up, down, up, down, up, down, up, down. So irrespective of open end or close end, we can have what? Wave. Because later on in the topic we are going to discuss about open air column also. Okay. So my wave can be both. Okay, it can be plus pi or without plus pi. If you are using plus pi, we know that sine of pi plus theta, sine of pi is in third quadrant. So sine of pi plus theta will be in, sine of pi is in the second quadrant, end of the second quadrant. This is what pi is. So pi plus theta is going to be in my third quadrant. Okay. So you can have two types of equation. Don't get tensed or don't get worried. If I use this, I am going to get minus sine of kx plus omega t. You can either use this equation, or if the end are open, then what will be your equation, sir? A sine of kx plus omega t. So this is my wave. This is the wave which I am sending in positive direction. If the end are closed, I will be getting this wave. If the end are open, I am going to get this wave. Any difficulty? End are closed, this wave. End are open, this wave. Any difficulty? I don't think you should have any difficulty in this. You can take any two wave and add. This is my wave and this is my another wave. You can take like that. Okay. So there is no issue in it. So y1 plus y3, or you can have y1 plus y2 also. That is not at all an issue. If I open this, what will I get? Sine of a minus b. Sine of a minus b can be very well written as sine a cos b minus cos a sine b. Okay. If I take this equation, it is going to have just a minus sign. this is going to have a plus sign, so no difficulty. If I take this sine of a plus b, sine of a plus b can be written as so if you see this term and this term is going to get cancelled. So what will I get, sir? y1 plus y3 a, right? So actually 2a sine of kx cos of omega t. Any difficulty, sir? Sine of kx cos of omega t. If instead of this I have taken my wave and this wave is reflection from open end, if instead of this I am taking wave plus reflection of wave from closed end, if it is from closed end I am going to get sine of, so y1 plus y2, we are going to just add y1 plus y2. So we are going to get same addition, but in between we have a negative sign. So what will be my answer? Sin kx cos omega t minus cos kx sin omega t. Now we have minus sign. So minus sign of kx cos omega t and minus cos of kx sin omega t. Right? If we do this, what will happen, sir? This term and this term gets cancelled. So what will be my answer? Minus 2a cos of kx sin of omega t. So this is the equation of standing wave. This can be equation of standing wave. Okay. Also, there are two other equation of standing wave. So standing wave can be in any form. Either sin kx cos omega t, cos kx sin omega t, or you can have my equation as, so this is not equal to this, okay, so this is one equation, this is another equation, and minus is representing that it is going to have an opposite phase, that's it, nothing else. You can have 2a sin of kx sin of omega t, or else you can have 2a cos of kx cos of omega t. All the four are equation of standing wave. All the four are what? This one, this one, this one, this one. All the four are equation of standing wave. How do we get standing wave? One wave is going in forward direction, another wave is coming in backward direction. They are going to superimpose. That's it. Either it can be along, that is from the open end, so it is going up, coming up, or it can be closed and going up, coming down. Both are possible. Just remember this. And these four are equation of your standing wave. Okay. Now where are the point? So if I am seeing this, so let me say this is my wave, this is another wave. These two waves are going to superimpose, and we found what? There are certain points which are not moving at all. This point will have zero displacement. These both points are going to have what? Zero displacement. So even in this, if I see, actually, okay, let me have fixed end. Okay. And the frequency little bit I am going to reduce. I am unable to find what will be the frequency of this. Okay, so I don't know the wavelength. It is doing something. Okay, so what is happening, sir? There is one wave going, another one is coming, and they both are superimposing. And if you see, we are going to get something like pulse, right? See, the amplitude is 0.5. Okay, but we are getting a height which is more than that also. If I increase this to 3, my amplitude will reduce. What happened now? Last time we got a wave, this time we are not getting a wave. Fixed end, right? The ends are fixed. Let me reduce the amplitude. Okay, okay, okay. I got it. I got it. Okay, if you actually 1.5 is quite okay, but at some point it is getting glitched. So if you are see, okay. So if you see this point, actually there is some glitch in this, okay, because I am unable to exactly find that. So if you see this particular point, let me show you in some other thing, okay. This one is better. If you see this point, this point, this point and this point, these 4 points are not at all moving, they are at rest. So this is called node, okay. And if you see the wave, it is going up and down, up and down, up and down about this position, up and down, up and down, up and down about this position. So the place where we have zero displacement is called node, and the place where we have maximum displacement is called what? Antinode. So node and antinode, okay. So if I take my equation is equal to 2a sine of kx minus omega t sine of kx cos of omega t. I want the place where my amplitude is 0. I want to find where will my amplitude be 0, okay. So in order to get amplitude 0, my sine of kx value has to be 0. We know that what are the places where sine is 0? Sir, sine can be 0 when we have 0, pi, 2 pi, 3 pi and it goes on. So generally I can tell my kx, okay, my kx, so k can be written as 2 pi by lambda. My 2 pi by lambda should be integral multiple of pi, correct? So what will I get x from here? From here I will be getting, if I cancel this pi, I will get n lambda by 2. So whenever my wavelength is equal to 0, lambda by 2, 2 lambda by 2, 3 lambda by 2, remember this, okay, very much important, 2 lambda by 2, 4 lambda by 2, wherever I have this one, I am going to get what? I am going to get what? Nodes. So if I talk about this, okay, if this is my complete wave, so this is my wavelength lambda. At 0, I have node. At lambda by 2, half of the wave, I have node. 2 lambda by 2, I have node. 3 lambda by 2, I have node. Are you able to follow? So whenever I have lambda by 2, 2 lambda by 2, 3 lambda by 2, I am getting what? Nodes. Nodes means zero displacement. So the position where I am going to get node is lambda by 2, 2 lambda by 2, 3 lambda by 2. For antinodes, I should have maximum displacement. What I should have? I should have maximum displacement. Sir, we are getting confused between nodes and antinodes. If you see my wave is like this, going upward and coming in this direction. It is like this. So these are the point where my amplitude is what? 0. If you see there, two waves are getting knot. So not node, remember, knot means node, okay. We are putting some knot, so that it is not moving, so node, okay, not moving node, you can remember like that. And in antinode, my displacement has to be maximum. It means that my sine of kx value should be maximum. What is the maximum value possible for sine? Sir, 1, sir. What are the places where we are going to get sinus 1? Sir, we are going to get sinus 1 whenever angle is pi by 2, 3 pi by 2, 5 pi by 2, etc. So k can be written as 2 pi by lambda into x. What can be the general form? Sir, 2n minus 1 pi by 2. Correct? So if I put n is equal to 1, I am going to get my first node, next second, next third. So what is my value of x? X is equal to 2n minus 1 lambda by 4. So whenever I have put n is equal to 1, lambda by 4, 2, 3 lambda by 4, 3, 5 lambda by 4, 4, 7 lambda by 4. So whenever my wavelength is equal to lambda by 4, 3 lambda by 4, I am going to get what? Maximum. If you see this distance is lambda by 2. So this will be lambda by 4. So lambda by 4, this distance is going to be 3 lambda by 4. This distance is going to be 5 lambda by 4, right? Any difficulty? So whenever my distance is lambda by 4, 3 lambda by 4, 5 lambda by 4, I am going to get a maximum. That is what we called it as antinode. Any difficulty so far? Nodes and antinodes. So such point where the resultant amplitude is 0 is called node, and where the resultant amplitude is maximum is called antinode. Any difficulty in that? So modes of vibration. Okay. The minimum frequency, the lowest possible frequency is called fundamental mode or first harmonics. Okay, fundamental mode or first harmonics. So for three things we are going to see this vibration. One is for string, another one is for open, another one is for closed. So I am going to teach string and close first, because string and closed are almost the same. Okay, in string both ends are closed, so the particle has to vibrate in between only. And in closed pipe, okay, not in closed, I think we will first discussing open, then we will go to close. Okay, close, open means both the ends are open. Okay, I will tell you, don't get confused. Closed means one end is closed, another is open. So don't get this closed and that closed confused. I will teach you, don't worry at all. So the lowest possible frequency is called fundamental or first harmonic. So you should remember the name, first harmonics. Next frequency is called second harmonic. Next frequency is called third harmonics. So fundamental, or what we call first harmonics. Next one is called second harmonics. Next is called third harmonics. Next is called fourth harmonics. This second harmonics is called first overtone. Third harmonics is called second overtone. Fourth harmonics is called third overtone. These things you should remember. Okay. So consider a uniform string. I am going to have a uniform string. I am going to fix both the end of this string, sir. Both the end are what? Fixed. I can vibrate this string. Just remember, my frequency, wavelength into frequency is equal to velocity. So my frequency is nothing but velocity by lambda. So in all the things, you just need to know what is the relationship between wavelength and length of the string. If you know what is the relationship between wavelength and length of the string, just take the value of wavelength and substitute over here. You will get the answer. And velocity, as we have already seen, velocity can be written as T by m, T by mu. So generally we don't use this formula very much often. Okay, so don't get worried. But I have taught you, right, how to solve question in last lecture, not last lecture, before that. We have in velocity of wave, we have discussed how to find the velocity if these terms are given. So generally remember in this format, if they are asking in this format also, I don't think you should have any difficulty in it. Okay. So for first harmonics, what do I mean by first harmonic? My wave is going upward, and after reflection my wave is going to come downward. Okay. Just note all the things whatever I am telling. Seringla. Purida means are you able to understand? That's what I meant to say. Any difficulty so far? Okay, sir. So this is the length. Length of the string is going to remain constant. But this length is equal to how much in wavelength? If I draw a wave like this is my wavelength. So what will be this, sir? This is my wavelength by 2. So can I write L is equal to lambda by 2? So lambda, L is equal to lambda by 2. So what will be my lambda, sir? Lambda is equal to 2L. So this is the relationship that you need to find. What is the relationship between wavelength, wavelength and length? Okay. My frequency can be written as velocity by wavelength. So instead of this, if I substitute 2L, this is my fundamental frequency, what I called as F1. Very, 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 very important. Remember this. Okay. velocity by 2L. So for first harmonic, this is called what? First harmonics. In first harmonics, how many nodes I have? One node, two nodes. So two nodes, sir. Two node. How many antinodes, sir? One. Sir, this is antinode, this is antinode. So we have two antinodes? Wave is either up or down. At the same time, it is not up and down. Okay. So when wave is up, we are going to have antinode up. When it is down, down, up, down, up, down, up, down, up, down, up, down. So at the same period of time, we are not going to have two antinodes, right? Either it is up or down. Are you able to follow? Okay. Now let us discuss about second harmonics. Okay. Same slide has been repeated. So second harmonic, second mode of vibration or second harmonics. The same length is L, but now wave is going to go like this. So the reflected wave will be coming like this. This is what is my second harmonics. So this is my length L, and this L is equal to what, sir? One complete wave. So my length is equal to wavelength. So wavelength is equal to L. Can I write this as 2 by 2? Sir, why, sir, unnecessary things? There is some point in it. So my frequency is equal to velocity by lambda. Velocity by lambda. Lambda can be written as L. Or can I write this as 2V by 2L? Yes, sir. But why, sir, unnecessary thing? What is this? Sir, V by 2L. V by 2L is my fundamental frequency. V by 2L is my fundamental frequency. So can I write second harmonics as, my second harmonics is 2 times first harmonics? Yes, sir. So that is why I wrote V by 2L. Okay. So this is called second harmonics. Second harmonics can be written as first overtone. Second harmonic or first overtone. Any difficulty? How many nodes are? 1, 2, 3 nodes and 2 antinode. So second harmonics means 2 plus 1. 2 plus 1 antinodes and 2 nodes. Sorry, 2 plus 1 nodes and 2 antinodes. Okay. If I talk about third harmonics, same length L. Okay. Is like this. Okay. So this is lambda by 2, lambda by 2. So already I have taught you, right? So antinode is formed only when we have lambda by 2. So lambda by 2, 2 lambda by 2, 3 lambda by 2. So my length is going to be 3 lambda by 2. Okay. So what, how can I write wavelength? Wavelength is equal to 2 by 3 times L. Okay. My frequency is equal to, my third frequency is equal to velocity by wavelength. So what I get? Velocity by 2L by 3. Can I write my F3 is equal to 3 times F1? This is called third harmonics, second overtone. How many nodes? 1, 2, 3, 4. 4 nodes. Okay. So whatever is harmonic, if I have nth harmonics, n plus 1 node. And 3 antinode. 1, 2, 3. Okay. So at one time we are going to have 1, 2, 3. While reflection 1, 2, 3. Okay. So for general, how can I write? For general, my frequency is going to be, my frequency is going to be what? N into V by 2L. Can I write this as N times F1? So my nth frequency is equal to this one. This is called nth harmonics. And n minus 1th overtone. Because third harmonics is called what? Second overtone. How many nodes will I have? Nth harmonics will have n plus 1 node and n antinode. Because both the end are fixed. Okay, so we have one extra node. Remember like that. Let me show you all this very quickly. So if I have first harmonics, this is first harmonics. Okay. What will be my length, sir? Length will be half of lambda, right? So let me show length. 0.5 lambda. If you see this, okay, I can't speed it up. Okay, no issues. If you see this, one node, two node, and I have one antinode. See, one antinode. In second harmonics, my wavelength is equal to lambda because lambda by 2, lambda by 2. So lambda by 2 plus lambda by 2 is equal to 2 lambda by 2 or lambda. If you see 1, 2, 3. So in second harmonics, I have three nodes. And how many antinodes? 1, 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Purida. In third harmonics, see lambda by 2, lambda by 2, lambda by 2. So 3 lambda by 2 or 1.5 lambda. If you see 1, 2, 3, 4, I have 4 nodes. And how many antinode I have? See this. 1. So this 2 and this one. This 2 and this one. So totally 3 antinodes. Any difficulty? So this is the general formula that you can remember. So before talking about closed organ pipe, let me talk about open organ pipe. This open organ pipe is going to have both ends open. Open organ pipe is going to have what? Both the ends are open. Okay. So let me try to quickly summarize everything. So both the ends are open. If I draw a complete wave, this is my complete wave, sir. This wave is starting from down, it is going till up. So this wavelength is lambda. If I cut this part and this part, this will be my lambda by 2. So as we have discussed earlier, in string also and in open pipe. Okay. So this is not in closed pipe, this is open pipe. Okay. Let me quickly change some things. Okay. So with the power of editing, we have changed everything. Okay. So actually where did it go? Okay, here it is. So for first one, I am going to have a wavelength of what? Lambda by 2. For second harmonics, what will I have, sir? From here till here, this is a complete wave. So lambda by 2 and lambda by 2. So can I write it as 2 lambda by 2? Next what I have? Sir, from here to here lambda by 2. From here to here lambda by 2. From here to here lambda by 2. So I have 3 lambda by 2. Any difficulty? So same thing we are going to repeat. No issues. Okay. But only difference is both the ends are open. So after reflection, what will happen? This will come down. Okay. This will come because both the ends are open. Remember this. So if I talk about fundamental or first harmonics, what is my length? My length is equal to lambda by 2. Any difficulty? My length is equal to what? Lambda by 2. So my frequency is equal to velocity by wavelength. What is my wavelength, sir? 2L. Sir, same thing we got in string also. Yes, remember both are same, but there is a difference. In first harmonics, last time we have both the end fixed. So we had, if it is nth harmonics, we had n plus 1 nodes and n antinode. But here both the ends are open. So here you see one antinode, two antinode. So I have, in first harmonics, I have two antinodes. And how many node I have? One node. It is just ulta. Ulta means opposite. So in previous case, we saw if it is first harmonics, then two nodes because both the ends are fixed. Two nodes and one antinode. But here two antinode because both ends are open. So two antinode and one node. If I talk about second mode of vibration, you can see lambda by 2 over here, half wave here and half wave here. So my length is equal to 2 lambda by 2. 2 lambda by 2, right? So my frequency F2 is going to be velocity by this one. Sir, same thing we are getting, yes, but only difference is what? This is called second harmonics. Okay, and it is second harmonics and first overtone. Okay, they have just copy pasted things. Okay, it was first overtone, they have just copy pasted, so they have made a mistake over here. So it is first overtone. Second harmonics are first overtone. How many node I have, sir? 1 and 2, because second harmonics so 2 node. If it is nth harmonics means n node. How many antinode? 1, 2, 3. So 3 antinode. third mode of vibration, or we call that as third harmonics or second overtone. Okay, so third harmonics or second overtone. If you see here, lambda by 2, lambda by 2 and lambda by 2, so 3 lambda by 2, so my length is equal to what? 3 lambda by 2, so my wavelength is equal to 2L by 3. My frequency is going to be velocity by, so can I write F3 is equal to 3 times F1? My F3 is equal to what? 3 times F1. Any difficulty? This is called third harmonics, right? Second overtone. Third harmonics will have 3 notes and 4 antinodes. 3 notes and 4 antinodes. If you see 1, 2, 3, 3 notes, antinode, 1, 2, 3, 4, 4 antinode. Any difficulty? No, sir. Okay. So generally, actually, the PPT is getting me confused. Copy over here, paste it over here, and there we have to change it as not open. So later on it should be closed, right? This should be closed. Okay. So for open pipe in general, if it is nth harmonics, what I can tell, it is n minus 1 overtone. In nth harmonics, my frequency is going to be at n times frequency of fundamental. N times frequency of fundamental. If it is nth harmonics, I am going to have n notes and n plus 1 antinodes. Okay, so you need to compare all the things, then only you can remember it easily. Next we have what? Closed organ pipe. This closed organ pipe is little bit different. Okay, so in previous thing we saw distance is equal to lambda by 2. Here we are going to have this distance is equal to lambda by 4. So if I am completing a wave, my wave is going to get complete over here. So from here to here it is lambda by 2. So this distance is equal to what? Lambda by 4. So before going to this, let me quickly show you open air tube. So first one, if you see after reflection it is going up and down. So this is what is my first harmonics. First harmonics. This point is not moving. This is called node, and these 2 points are antinode. For second harmonics, okay, from here to here lambda by 2, here to here lambda by 2. So lambda by 2, lambda by 2. Okay, so it is having integral multiple of lambda by 2. So if you see this one, I have node. So 2 node and 3 antinode. So in second harmonics, 3 antinode and 2 node, right? In third harmonics, lambda by 2, lambda by 2 and lambda by 2. So 3 lambda by 2 or 1.5 lambda. Node. So third harmonics, 3 node. 1, 2, 3, 4, 4 antinodes. Any difficulty? Because the lecture should have a duration of 1 hour, so I have just a little bit pushing. Okay. If you have any doubt, please feel free to ask. So what is my length? My length is equal to lambda by 4. Okay. What will be this one, sir? Sir, from here to here it is lambda by 4, and here to here lambda by 4 and lambda by 4. So I am getting lambda by 4, lambda by 4. Previous cases, in all previous cases it was lambda by 2, 2 lambda by 2, 3 lambda by 2, 4 lambda by 2. But here it is lambda by 4. Next we have 3 lambda by 4. See, lambda by 4, lambda by 4, lambda by 4. So 3 lambda by 4. Next length is going to be lambda by 4. Next lambda by 4, lambda by 4, lambda by 4, lambda by 4. So 5 lambda by 4. Any difficulty? Any difficulty? So if I am talking about first mode of vibration, so first mode of vibration is called first harmonics. First harmonics. In closed pipe, okay, remember this, in closed pipe, we don't have both end close because it is air column. So there should be hole to blow air. If I close both the ends, sir, can I blow air in it? No. So in closed pipe, don't consider that both ends are closed. If I tell a string, closed means both ends are fixed. Open means both ends are open. But for closed organ pipe, one end is closed. How do we close that? We pour some water. So if we pour some water, that end cannot move, right? So closed organ pipe will have one end open, okay, other end is closed. So remember this, one end is closed and one end is open. In open air column, both ends are open. In closed, one is open, one is closed. In string, both ends are closed. So these are the things you should remember. So first harmonics, my frequency is equal to velocity by wavelength. What is my wavelength, sir? My wavelength is equal to lambda by 4. So my is equal to 4 times lambda. So if I just put it over here, I get V by 4L. Previous cases, what we got? V by 2L. But here, V by 4L. This is the difference between open and close. Okay, open and close. Remember this. There we got V by 2L. Here we get V by 4L. Okay. Number of nodes. So it is first harmonic. So one node and one antinode. Because one end is open, one end is closed. If both ends are closed, we get one extra antinode. Sorry, we get extra node because both the ends are closed. If both the ends are open, we get extra antinode. Here we have one end open, one end closed. So equal number of antinode and equal number of node. If I talk about second mode of vibration, or what we call that as second mode of vibration, is called third harmonics. We don't have second harmonics. Why don't we have second harmonics? Second harmonics means this is the case. This is my second harmonics. So lambda by 2 plus lambda by 2. If this is the case, then doesn't it look like string closed at both ends? But organ pipe cannot be closed at both the ends. So therefore, second harmonics is not possible. So after first harmonics, we have third harmonics. Third harmonics is called first overtone. First overtone. What is my wavelength? Lambda by 4, lambda by 4, lambda by 4. So L is equal to 3 lambda by 4. So my frequency is going to be 3 times, right, V by 4L. So my F3 is equal to 3 times F1. In all the previous cases, okay, it was F1, next F2, next F3. So F3 is equal to 3 times F1. Same thing we got, but difference is V by 4L. There it was V by 2L. So remember this. How many nodes, sir? 1, 2. It is second mode of vibration. As it is second mode of vibration, okay, second mode of vibration. So it has 2 nodes. And how many antinode? 1, 2. So 2 antinode. Third mode of vibration. Third mode of vibration is called what? Fifth harmonics. Okay. My length is equal to 5 lambda by 4. My frequency is equal to 5 times F1. How many nodes? 1, 2, 3. So 3 node and 3 antinode. So generally, how can I write, sir? For nth harmonics. So first harmonics was first one. My first one was first harmonics. But my second one was third harmonics. My third one was fifth harmonics. So only odd number are coming, sir. So my nth one will be nth mode of vibration. My nth mode of vibration is going to have 2n minus 1. Why, sir? If I put n is equal to 1, I get 1. N is equal to 2, 3. N is equal to 3, 5. It will be 2n minus 1 harmonics and nth overtone. How do you know, sir? Actually, n minus 1 overtone, I am sorry. Because for n is equal to 2, first overtone. N is equal to 3, second overtone. This is called second overtone. So it is n minus 1 overtone. So as usual, we got n minus 1 overtone. How many nodes it will have? Nth mode of vibration will have n nodes and n anti-nodes. Okay. So let us summarize all the modes of vibration. I have string, basically closed at both the end. I have open air column, open at both the end. I have closed air column, open at one end, closed at another end. Open air column. So open at one end, closed at another end. In mode, okay, if it is n mode of vibrations, so generally let me write from n is equal to 1. So what is the frequency? F1, which is equal to V by 2L. Here F1, which is equal to V by 2L. Here F1, which is equal to V by 4L. Don't get confused. For n is equal to 2, for n is equal to 2, I get F2 is equal to, right, 2 times F1. Here I get F2 is equal to 2 times F1, right? Here we don't have second harmonics. So for n is equal to 2, we get what? Third harmonics. Okay. So what will you be getting? F3 is equal to 3 times F1. For n is equal to 3, F3 is equal to 3F1, F3 is equal to 3F1. For n is equal to 3, here we get F5 is equal to 5F1. Any difficulty? So for nth mode, it is going to be Fn is equal to n times F1. Fn is equal to n times F1. For 3, it is 5. So Fn is equal to n minus n times F1. How many nodes do we have? For nth one, we will have n plus 1 node. N plus 1, sorry, n nodes, because here both the ends are open. So n nodes. Here n nodes. Antinode. The antinode, number of antinode is going to be n antinode. Here n plus 1 antinode. Here antinode, okay. Here we will be having n antinode only. If I find the difference between two consecutive things, okay, so Fn minus Fn minus 1. If I find the difference between these two, what will I get, sir? Fundamental frequency. If I find the difference between these two, what will I get, sir? Fundamental frequency. If I find the difference between two consecutive things, what will I get, sir? F1. So if they are asking about closed pipe, if the difference between the two consecutive frequency of a closed pipe is this, then what is the answer? So it should 2F1. So from that, if they ask fundamental, 2F1 is equal to some value. So find F1. Now let us quickly solve few questions based on this. A cylindrical tube open at both ends. Both the ends are open. Fundamental frequency is F. So can I write F as V by 2L? Because for open pipe, this is the formula. So this is my pipe which is open. Okay. The tube is dipped vertically in water. If I am taking this tube and dipping it to half the length. Same tube I have taken. Now I have dipped this tube in what? Water. Until where we have water, sir? Water is still half of the tube. So what is the length of the column remaining? Because this thing is completely dipped. So what is the air column remaining? You should not see what is inside the water. The length of the air column is matter. So length of air column becomes L by 2. Initially it was L. Now because half of the thing is in water, the air column, the length of air column is L by 2. So what is the fundamental frequency of closed pipe? Sir, V by 4L. What is the length of the tube? Sir, L by 2. If I cancel this, I get which is equal to my fundamental frequency. Are you able to follow? Any difficulty in this? So for closed pipe, use closed pipe formula. For open pipe, use open pipe. Now they ask me to compare the relationship between closed and open pipe. For a certain organ pipe, 3 successive. Okay, let's leave this question for now. A closed pipe of length 10 centimeter. There is a closed pipe whose length is what? 10 centimeter. Okay. Has its fundamental frequency half that of second overtone of open pipe. So there is a closed pipe. So they are telling fundamental frequency of closed pipe is equal to second overtone. Second overtone means third harmonics. So third harmonics of open pipe. Are you able to follow? First harmonics of closed pipe is equal to third harmonics of open pipe. Can I write this as V by 4L? Why sir 4? Because closed pipe. LC means length of the closed pipe. For third harmonics, it is 3V by 2L. This is length of open pipe. Any difficulty? This velocity gets cancelled. This 2 is cancelled with this. Okay. So what they are asking me? Okay, actually it is half. The fundamental frequency, this frequency is half that of. So it is half of this. So this 2 can cancel. So I am getting length of open pipe is equal to 3 times length of closed pipe. Length of closed pipe is 10 centimeter. So 3 into 10, which is equal to 30 centimeter. Any difficulty? 30 centimeter. Okay. So you should understand how to write this as equation. Closed pipe, so this is closed pipe, has fundamental frequency, the fundamental frequency of closed pipe is half that of third overtone. So third overtone can be written as what? 3V by 2L. So half into 3V by 2L. Any difficulty? A certain string resonates with several frequency. Lowest frequency is 200, sir. There is a string which is resonating with frequency 200. So F1 is equal to 200. What will be the next consecutive thing? F2. F2 is nothing but 2 times F1. F3 is nothing but 3 times F1. F4 is nothing but 4 times F1. So if I substitute F1 is equal to 200, I will get 400, 600, 800, right? Any difficulty? If they are talking about, let me say if they are talking about, good thing, open pipe, then same answer. If they talk about closed pipe, then F1 is equal to 200 for closed pipe. If they talk about closed pipe. Next what will be the thing? F3, which is equal to 600. What will be the next thing, sir? 1000. Okay. So closed pipe, remember F1, 3F1, 5F1. Two nearest harmonics of closed pipe. Closed pipe, next harmonics. Okay, neat question. Next harmonics of closed pipe. One is 220, another one is 260. Okay. So for example, if this is F1, what is the next thing, sir? F3. Correct. So F1, F3. So what is the difference between two, sir? Difference between two consecutive thing is called 2 times F1. In what? Closed pipe. I have taught you that, right? So here, difference between two consecutive things is equal to 2 times F1. So my 2 times F1 is equal to what, sir? 40. So my F1 is equal to 20. If instead of closed pipe they have given string, if they have given string or open pipe, then my F1 is nothing but subtract both. So this is for open or string. For closed, this is the answer. Any difficulty? So same question repeated. Okay. So with this, we have winded up this topic. Try to solve more and more PYQ based on this. Okay. So for summary, I have given everything is precisely provided over here. Okay. So this is your summary. If required, I can just copy and paste it. Okay. I can copy and paste my summary part over here. So this you can use for your revision purposes. Okay. So this will be our summary part. These are the things which we have discussed. So this is very much important. Remember, questions are continuously being asked. So try to solve more pre-YQ based on NEET and JEE level questions. Okay. If you have any doubt, please do let me know. Thank you so much and have a nice day.